Hey guys, welcome back. So we have a question, a gas law question. You can tell because there's liters, pressure, temperature in there, where we have one chamber that has hydrogen gas, and we have a second chamber that has oxygen gas. They're separated from each other, but then you open the chambers and a reaction happens, and they form water. We're going to figure out the total pressure in the apparatus. So let's focus on, for right now, this part. So not all gas chamber questions have an actual reaction. So we have hydrogen gas. Let's write this down. We have hydrogen gas reacting with oxygen gas. And forming water. Water vapor. So the vapor part lets us know that it's a gas. We might as well balance this equation because we have it up here. Cool. This will help us throughout the entire question. And we want to know the total pressure in the apparatus. So probably what we're going to be doing, let me actually undo that line. Total pressure is the sum of all the pressures of the gases there, right? So we definitely have a pressure of water, right? Because this is a product. However, both of these are reacting and one of them is going to run out, right? You can't keep having hydrogen react with oxygen and one of them is going to run out first. So one is the limiting reagent. That means the other one is going to be in excess, right? So we for sure have water because it's a product. We're also going to have the pressure of the leftover gas, whatever gas is in excess, right? So what is it going to be, oxygen or is it going to be hydrogen? We don't know. To find out, we realize that either hydrogen or oxygen is going to run out first, and that makes it a limiting reagent question. And just to recap, in limiting reagent questions, the way you solve them is convert from the moles of your reactants to moles of your product. So we're going to do that. We're going to convert from moles of hydrogen and oxygen to moles of water and see which one is the limiting reagent. So I'm going to go ahead and get rid of that. So we're not actually given, clean this up, we're not actually given the moles of hydrogen or the moles of oxygen, but we're given volume, we're given pressure, and we're given temperature. That's kind of setting us up to use PV is equal to nRT. So let's go ahead and do that. I'm going to get rid of this up here. Cool. So right now we're figuring out which reactant, which gas reactant is the limiting reagent. So for oxygen, we have a pressure of 3 atmospheres, a volume of 2 liters. PV is equal to N. R is always the same. Times the temperature, so 400 Kelvin. Cool. This leaves us with 0.18 moles of oxygen. Let's go ahead and convert that to the product to see how much water we would make with this 0.18 moles of oxygen we have. To convert from moles of reactant to moles of product, you need to use the mole ratio from the balanced chemical equation. And so that's why it was important for us to have balanced that already. We know for every 1 mole of oxygen, we're going to be producing 2 moles of water. So if this were the case, we would be making 0.36 moles of water. This isn't enough to let us know the actual amount of water we made. We have to do it for hydrogen gas as well. So we're going to do the exact same thing. Find moles of hydrogen gas, convert it to product, see which is the limiting reagent. All right, cool. And we end up getting the same number, 0.18 moles of hydrogen, right? You can pretty much tell because everything is the same except for the numbers here are switched. So obviously you're going to get the same numerical value, 0.18. cool. And then converting to moles of reactant. So for every 2 moles of hydrogen, 2 moles of water, getting that from the balance equation. So this amount of hydrogen gas that we have can only make 0.18 moles of water. So this is how much water we're actually going to make, because we're going to run out of hydrogen gas. So we cannot make this 0.36 moles of water because we run out of hydrogen gas first. This lets us know a couple things. This lets us know the amount of water formed. This also lets us know that hydrogen is the limiting reagent and runs out first, which means that oxygen is the excess gas. This helps answer our question earlier, where our leftover gas is going to be oxygen, right? We can't write pressure of hydrogen in here because hydrogen was a limiting reagent. It was all used up. It doesn't exist anymore after the flask is opened and the chambers are connected. So if we can go and update this, we know that the leftover gas, leftover excess, sorry, I wrote that, leftover gas is what I meant, because leftover excess is redundant. Okay, cool. So now we just need to find the pressure of water and the pressure of O2. Let me go and clear up this part. Actually, no, I'm not going to clear that up yet. We can find this a couple ways with PV is equal to nRT. Right? We could also find this with PV is equal to nRT, right? Because we already have the volume. The volume is now going to be combining both halves of the chambers. We have the temperature. All we need is the moles, right? All we need is the moles, right? We already know the volume, we know the temperature. We just want to find the moles of oxygen that are left over. So let's go ahead and do that. I'm going to go ahead and pause and clean up the important information. I'm just going to highlight the important information first. So maybe you should pause and think about what information we're going to use. Definitely going to use the amount of oxygen that we started with, and definitely the amount of water that was formed. Okay, welcome back to this nice clean board with the amount of water that we formed and the amount of oxygen that was there. We already calculated that. So we want to find the moles of oxygen that's left over, because from there we can use PV equals nRT to find the pressure of oxygen left over. As with anything that's left over, it's the initial amount, so moles of oxygen initial, minus the moles of oxygen that was used. So you've definitely seen a question with some kind of excess or leftover. We actually already figured out the amount of oxygen initially, right? We have 0.18 moles. That's what we did with PV equals nRT at the beginning. We did PV is equal to nRT with these numbers to figure out the moles that were present. So we know this is 1.8 moles. We already calculated that. The tricky part is calculating how much is used. Well, it was used to do what? The oxygen was used to make water gas. So used to make water. And how much water did we make? 0.18 moles used to make 0.18 moles of water. Right, as always, like you've seen me say this in the other videos, the amount used, you want to base it off the theoretical yield or the amount of product that you make. Both of those mean the same thing. The amount of your product made. All right, cool. So let's go ahead and do that. We know that we have 0.18 moles of water made. And we're going to use our balance equation to help us connect moles of water made to moles of oxygen used. We see that for every 2 moles of water made, there's 1 mole of oxygen that's used. So what we're left with is 0.09 moles of oxygen that's used. All right, cool. So this lets us know that our moles of oxygen left over is our initial amount, 1.8, minus the amount used, or 0.09 moles of oxygen. Cool. So I'm going to go ahead and pause again and clear this up. Left over. I'm going to add this number to our important chart. Okay, cool. So we said that we were going to use PV equals nRT to find the pressures of each of these gases of water and of the oxygen, and then add them up to find P total. So that's actually one way we're going to do it, by using P total is equal to the pressure of water plus the pressure of oxygen. But we're also going to do it a second way, where we just do PV is equal to nRT just once, where you plug in the total pressure, you have to use the total volume, and you have to use the total amount of moles of gas. Right, so we're going to do this two different ways, and we're going to get the exact same answer. So first, let's find the pressure of water. The pressure of water. PV, we're going to use PV equals nRT for this side. The volume we have to remember, originally there was 3 liters on one side and 2 liters on the other side, so when you open them up together, there's a volume of 5 liters. Oops. It's equal to the moles of water, which we just realized, or we figured out we have 0.18 moles of water times R times the temperature. So then we get that the pressure of water is around 1.18 atmospheres. Cool. We do the same for oxygen, where the pressure of oxygen is equal to the volume of oxygen. The moles, we realize we have 0.09 moles left over after the reaction. And 400 Kelvin. The pressure of oxygen is equal to 0.59 atmospheres. So our total pressure, when we add them up, would be somewhere around 1.77 atmosphere. Notice that when we did PV equals nRT, the liters was the same, R was the same, and temperature was the same. The only difference was moles. So now we're going to do it the second way, and it'll work out the exact same. Right, so the total pressure, we're looking for that. The total volume is 5 liters. The moles total, we have to add the moles. So we have 1.18 moles of water, and we have 0.09 moles of oxygen. We have our R. I guess I can get rid of this now. It's not important anymore because we're almost done. Goodbye. So for R, 0.08206, and we have our temperature, so 400 Kelvin. Plug that in, and your total pressure ends up being 1.77 atmospheres. Well, so now you have 2 ways to solve the same problem. The only reason this P total worked, this formula worked, was because volume was going to be the same for both. R was going to be the same for both. And temperature was going to be the same for both. So you might as well just add up the moles and do it that way. Anyways, I hope this helped. Let me know if you have any questions in this video. You can be like, oh, can you go to this video and look at second, like 3 minutes, 7 seconds, and like, where did you have a problem? All right, have a nice day.